What is going on, everyone, and welcome to the Fusion 360 tutorial series. This is day 5 of learning Fusion 360 in 7 days. This tutorial is for complete beginners with Fusion 360 in order to learn the ropes from sketching our first component to assembling geometries by day 7. Today, we will be diving into the world of assemblies and connections, introducing how multiple components can interact, move, and fit together within Fusion 360. We will learn about the different types of joints and constraints while assembling together this simple lamp design that I previously created. By the end of the day, you will have the basic tools to bring your designs to life with motion. Let's get into it. To start, it is critical to understand the difference between components and assemblies in Fusion 360. Like we've been creating throughout the entire series so far, components in Fusion 360 not only refers to the solid objects within the CAD, but also encompasses the environment that the object was created in, including the origins and document settings, as well as the other design elements such as construction geometry, canvases that we used in order to sketch, and the sketches themselves. Assemblies, on the other hand, on top of having its own environment, origins, etc., also contains 2 or more components. For example, if we wanted to fasten the nut and bolt that we created in the last episode, we could do this through an assembly. By creating these assemblies, we get to create motion studies to help understand how different components will interact with one another, as well as being able to perform stress analyses and create bill of materials, which are particularly necessary for manufacturing. Assemblies are an extremely important aspect to get familiar with in our CADing softwares. If we open up a new Fusion 360 design window, the program always sets up the environment for a new component as denoted by the little cube icon here, which, as mentioned, has its own document settings and origins. However, by adding multiple components to the same environment, the program will treat this collection of components as an assembly. Each component that we add will also have its own environment, setting, and timeline, which will also allow us to easily isolate and modify components on the fly while creating our assemblies. There are many different ways that we can add components to our assembly, either by creating new components directly within the assembly environment or by adding components that we previously created. To add components that we've previously created, you will go to the Insert section of the toolbar and press on the drop-down menu, and choose the first option that appears here, which is Insert Component. This will open up the File Explorer within your Fusion software to allow you to choose the part you want to add for your assembly. So I will start by selecting the base, press on Insert, and we can see that the component has been added to our environment. This window will open up on the side here, which allows the component that we are adding to the environment to be moved around, which just helps to see the components as they're being added so that they're not stuck inside one another at the beginning, since they always open up at the global origin of our environment. Now, in order to create assembly, we need a second component, so let's go ahead and add a second one as well. And let's move it out of the way so it's not interfering with the base that we added before. Now let's take a quick break to notice a few things about our environment. As mentioned earlier, we can see that the little cube icon that was used to identify that the file was a component has now changed to an assembly icon that looks like several cubes are assembled together. Our assembly has its own document settings, views, global origin, and timeline to indicate the steps that are going to be taken to assemble the components together. The design tree also contains the components themselves that we added that also have their own proper settings and timelines, which were imported from the file that we designed them in. You may also notice that on the first component that we added to our environment, a little anchor icon appears beside the cube. This means that the component is fixed and we can't actually move it. We can see that if we grab the move icon and select a few components to move, we can see that we can grab onto the beam and move it around, but it does not allow us to select the base since it is fixed. This happens to the first object that we add into the assembly, as it serves as a ground or an anchor point to build off of. Otherwise, our assemblies would be floating within our 3D environment, and we would not actually be able to effectively execute a proper motion study. We could also undo this by right-clicking on the locked component and pressing on unground from parent. This will remove the anchor icon, and if we grab the move command again, we can see that we are now able to select and move this component. Though for this assembly we will be making today, since this is the base of the component, I would suggest leaving it anchored, not to run into any problems during the motion analysis later on. Now that we have added our first two components within our environment, it is time to start assembling them together. This can be accomplished by creating a joint between the two parts to define their relationship and constraints. To create a joint, we will go to the Assemble section of the toolbar and press on the joint function, which looks like a door hinge being assembled together. That will open up this window here. In this window, we have two different tabs. We have the Position and Motion tab. In the Position tab, this is where we will choose to define the surfaces or features which will define the fit of the two components we are assembling together. And the Motion tab is where we can determine the type of joint and its motion constraints. In terms of the different motion types that we have available to us, if we press on the drop-down menu, we can see that we have rigid, revolute, slider, cylindrical, pin slot, planar, and ball motion types. The first type that we are going to explore for this assembly is the rigid joint. This locks two components' position relative to one another so that it doesn't allow them to move in displacement or rotation, which in other words means that this joint has 0 degrees of freedom. So if we choose the rigid joint and go back to the Position tab, for the selection of component 1, if we hover our cursor over the surface, we can see that the surface becomes highlighted and shows us many points that could be of interest to us, such as the intersection between two types of linear curves, center of lines and arcs, etc. For my first selection, I am going to hover over the bolt hole on the bottom side of my beam and select the center of the hole. As we can see, one component has been selected, and this component has become transparent to allow us to see all the other components for our second selection. And it will not allow us to actually choose the same component for the second selection, so that's nice. I will also note that the first selection or first component chosen will always move towards the second selection, which will always remain stationary. For my second selection, I'm going to choose a similar point on the top surface of my base, the middle of the bolt hole. And upon selecting this, we can see that the first component has moved towards the second one and has linked them together. Now that the components are connected, we have the option to adjust the alignment of the components, which is important since once we confirm this joint, the two components will be locked together. And we also have the option to flip the joint around, which again is useful if we need to reorient the joint, which may be facing in the wrong direction. If we press on the flip command, we can see that the two faces become flush with one another, whereas if we flip it again, we have it as before, where two faces are pressed up against one another. Since we can see that the two bolt holes are aligned properly, we can view the motion of the joint to ensure that the components are moving together as expected. So going back to the Motion tab, we can press on the little play button next to Preview Motion. As a result, we can see that the two components lightly shake together. This is Fusion's way of animating that the two components are connected together by a rigid joint. Since the motion of our joint is correct, we can press on OK to confirm this joint. And in the timeline, we can see that we have our two components followed by the joint icon indicating that a joint has been created after importing these two components. Now let's go ahead and add our third component. Press on the Insert icon and press on Insert Component and select Beam 2. and press on Insert. We will drag it up slightly by pressing on the arrow here and dragging it up so that we can see the whole component. Now we are going to connect the two links together in order for our lamp to have an adjustable arm. So press on the joint command, and the type of joint that we're going to use between these two components is a planar joint. This type of joint has 2 degrees of freedom, where the component is allowed to move in 2 linear directions from one another and is able to rotate about the perpendicular axis of that plane. Therefore, if we allow the components to be free in X and Y direction, we will also be able to rotate the objects about the Z axis. This is a typical joint that gets used for sliders and guides and is perfect for our application. If I go back to the Position tab, we can now select the 2 components we want to join. Remember to always start your selection with the components you want to move towards the other one. So I will start my selection with an area on my second link. Like we did for the bolt holes, I'm going to select the center of the hole where I would like to put a screw. And we can see with the selection made, the selected object has gone transparent, and we can now make our second selection. For my second selection, I'm going to go ahead and choose the center point of the bottom arc. This will serve as the bottom position of my allowable motion. If you see that based on the selection that you've made that the 2 components are intersecting with one another, you can always use the flip command, as noted by the 2 arrows in the menu here, which change the direction of the joint components. Now let's go back to the Motion tab and talk about motion limits. This describes the limits of motion that these components can move to in order to restrict their motion to something realistic within their free directions. What do I mean by this? Well, if we press on the play button beside the preview motion, this will show us how the components are allowed to move in respect to one another. And as you can see, our link detaches from the other one. Therefore, we need to set limits in motion to prevent this from happening. Now, I've already gone through the exercise of determining what these values should be. By selecting on the first button here, this will provide fields where I can go ahead and input our minimum and maximum values for rotation. So in this case, I'm going to go ahead and set my minimum value as negative 220 degrees and my maximum value as 35 degrees. Now, if we preview the motion of the link, we can see that the link is restricted to the rotation between these 2 values. And you may be asking how I determine these values, and honestly, I just kept changing them and previewing the motion until I got something that I desired. This is the same technique I used in order to get the height of motion I needed for my second link to move along my first one. To add this, I will go to slider 2 by pressing on the 3rd button here. And for the minimum value, I will put negative 142.3. If we preview the motion, we can see that my slider now slides from the bottom all the way to the top of my slot. Very cool. And since I'm restricting my link from having motion in the Y direction to prevent them from detaching, I'm going to leave slider 1 with no motion. So when you're happy with the motion limits, go ahead and press on OK. And there you have it. We have now added another component to our assembly. Oh shoot, you realize that while you're assembling your assembly of components, you realize that you're actually missing a component in order to complete your assembly. No problem, because we can actually insert a blank environment in order to create components right inside this assembly environment. To do this, we will press on the button beside the joint command, which if we hover it says new component. The type of component will be standard, and the type of component we will create is an internal component, which will make the component unique to this design assembly, and we will not be able to use it anywhere else. If we were to have chosen the external component, this would allow for the creation of the component within the assembly design, but also allow us to save it as a separate component to use elsewhere. I'm going to go ahead and name the component connection, and it will serve as the connection between the stand and the lampshade. And its parent will be the assembly we are designing. And make sure to press on activate so that the software jumps from the assembly environment to the components environment. So that is good to go. We can go ahead and press on OK. And as you can see, the assembly has become transparent, meaning that we have entered the components environment and we can start creating the missing link. If we hover the mouse over the current assembly, we can see that some of the edges are still selectable. This allows us to be able to custom design a component for our assembly, exactly where we want it. So let's start. Like always, we need to start with a sketch. As for the plane that I'm going to be sketching on, I'm going to sketch directly off of the second link, since this is where I want to be able to connect it later. And we're going to go ahead and grab the circle command, and we are going to snap it to the middle of the hole at the end of the second link. Let's make the diameter of the circle 40 millimeters. Next, we will grab the line command and draw some construction lines. So, from the center of the circle, we will draw a line horizontally to the edge of the circle, and do the same on the other side. Now we will convert these to construction lines by right-clicking and choosing Normal to Construction from the menu. Let's create some more construction lines, again from the center of the circle. But in this case, we will press on Tab to go to the angle dimension box and insert 25 degrees. And then drag this line out to the edge. And we will do the same thing to the other side. In this case, since we see that our 0 degree is the line with the previous line that we just drew, we will have to input 50 degrees to make it 25 degrees below horizontal like we have for the other one. Drag it out to the edge, and we will now convert these to construction lines. Now we will grab the line command again and draw some lines perpendicular to the ones we just drew. And these lines are going to have a length of 34.37 millimeters. And we'll do the same thing on the other side. And then we'll combine these two lines with another horizontal line. We're going to go ahead and grab the trimming command in order to get rid of some unwanted lines. Now with our sketch created, we can go ahead and exit sketch and extrude it by 5 millimeters. Finally, we will create a spherical object to be able to create a spherical joint to allow the lampshade to be orientated in almost any direction. To do this, we will use a pre-built sphere command in Fusion. Press on the Create drop-down menu and find the sphere command. Choose the end of the connection as the plane to build the sphere on, and place the center at the middle of the component and drag it 20 millimeters outwards as we were drawing a circle. The red sphere denotes that we are cutting away material, so we will want to change the operation type to join to add it to our existing body. Press on OK. And finally, we will use the fillet command to avoid this sharp corner here from the sphere to the adapter. Find the fillet command from the Modify section of the toolbar. This window will appear here. We will select the 4 edges we want to add a fillet to, and the fillet dimension will be 1 millimeter. Press on OK to confirm the changes. And there you have it. We have created the connection joint directly inside the assembly design without altering the properties of the assembly's environment. To get back to the assembly, hover the mouse over the parent in the design tree and press on the circle that appears to select it. And as you can see, the rest of the assembly is no longer transparent, meaning that we are ready to create a joint between the assembly and the newly created component. So first, let's left-click the newly created component and press on the Move Copy function. We are just going to move it out of the way slightly so that we can see both objects that we want to create a joint between. And now we are going to go ahead and press on the joint command. My first selection will be the center point of the hole on the connection. Upon selecting it, this component will become transparent, and we will go ahead and make our second selection, which will be the center point of the hole on the link. The two components will then connect together. If I move over to the motion tab, the type of joint I'm going to make is a Revolute joint, which is a 1 degree of freedom joint that restricts all linear movement and allows rotation about one axis. Perfect for this bolted connection. The first thing to check is the axis we want the components to rotate about. In this case, it would be the z-axis, since this is the axis that is aligned with the center axis of the hole. So that is good to go. We can also see that the sphere at the end of the connection is currently intersecting with the top beam. Therefore, we would also want to limit its rotation. Knowing that there's going to be a lampshade on the end of this connection, we should leave even more room than we think. So let's click on the checkbox and put 220 degrees as our minimum angle and 310 degrees as our maximum angle. Press on the preview button to see the motion, and I think that looks pretty good. So let's press on OK to confirm the changes. And finally, the last component is our lampshade. Like we did for every other time, we will insert the component into the environment, press on the drop-down menu and press on Insert Component, and browse for the component we want to insert. Press Insert. We will move the component out of the way to see the whole thing, and press on OK. Press on the Joint command in the Assembly section of the toolbar. In this case, my first selection will be the center point of the inner spherical surface on the lampshade. That will turn the component transparent, and then we can select the second selection, which will be the center point on the sphere of the connection piece. That will connect them together. As for the motion type, I will press on the drop-down menu and choose the ball type joint. Like the Revolute joint, this type of joint also restricts all movement in linear directions, but allows for movement in all three rotational axes. And finally, the limits on rotation to prevent any components from interfering with one another. We will have to set all the limits manually for each axis. To switch the axis, press on the next icon that is not selected blue beside the word motion. And do the same for the final axis. Now with all the limits in place, we can go ahead and verify the motion. First, we'll press on the checkbox on all limits. This will let the preview animate all the limits in all three rotational axes at the same time, rather than just showing the one that we have selected. So press on the play button. And I think that looks pretty good. Keep in mind that it is showing all the axes at once, which makes it look like it's not rotating off to the right side here. But if we deselect the all limits checkbox and preview the motion for each axis, we can see that the lampshade is going where we want it. The all limit preview tries to sum all the motion at the same time, so it doesn't necessarily show the whole story of what the motion actually looks like. Press on OK to confirm the joint, and there you have it. Our lamp is now fully assembled. And now we can check all the movement of all the components together in our assembly. To do this, we're going to go ahead and find the Move command in the Modify section of the toolbar, the icon of which looks like two intersecting arrows. That will open up this window here. For Object Move, we're going to go ahead and change this to Component so that we can select one of the components in our assembly. And we'll press on the lampshade, which will highlight the component and place some movement arrows beside it. If we click and hold the middle circle here, we can drag this component in any direction. And as a result, the assembly's components move based on their motion limits we provided. Very cool. So, all that being said, that will be a wrap for day 5 of learning Fusion 360 in 7 days. Today we explored how easy it was to create multi-body assemblies in the software, looking at the multitude of ways we can combine components through various joints, or even create components right inside the assembly. Watch out for day 6, where we'll take a look into bringing our creations to life with rendering and animations. If you found this video helpful, don't forget to leave it a like and subscribe for more engineering content.